Welcome back to primary supervised chemistry class part 2 on periodicity. Now, in this class, we'll be discussing on how to determine group, period, and block to which elements belong. But before we move on with that, make sure you check out the part 1 video to get better understanding as we move on. So now, when we are talking about the block, group, and period, what do we mean by that? So first, let's discuss about group. Now, the group represents the vertical column or the vertical section on the periodic table. So elements in the same vertical section or vertical column of the periodic table are in the same group. So there are majorly 18 groups on the periodic table. Each vertical section represents what? A particular group. So there are 3 things majorly you should note about elements in the same group. Firstly, elements in the same group, we have identical electronic configuration. Elements in the same group, we have the same number of valence electrons, and elements in the same group, we have identical chemical properties. That's what you should know. And second, we're talking about period. So when we are talking about the period represents the horizontal row on the periodic table. So elements in the same horizontal row on the periodic table are said to belong to what? Are said to belong to the same period. So you must know that. So there are 2 things you should note about elements in the same period. Elements in the same period have the same number of shells, and elements in the same period have different number of valence electrons. So that's we move on. Now, when I'm talking about the block represents what? A set of some particular elements unified by their atomic orbitals. So there are majorly 4 blocks on the periodic table, in which you have the SPDF block. You must have heard of the SPDF block to be what? Orbitals. But in this class, we are using it as what? The blocks. So now maybe you have a question, maybe in your WAEC past question, JAMB past question, or NECO. Maybe you are asked to determine the group, period, and block to which element belongs. So now in this class, we'll be dealing with that. For an example, we have lithium. So if you're asked to determine the group, period, and block to which lithium belongs, you can actually use the word electronic configuration. Now, the electronic configuration for lithium is 1s2 and 2s1. To determine the group is determined by the electron in the outermost shell, the valence electron. So now if you are going to check for lithium has 2 shells majorly, which is the what? First shell and the second shell. And the electron in the second shell is what? 1. That means lithium belongs to what? To group 1. That's the electron in the what? In the second shell. Now, secondly, to determine the period is determined by the what? The last shell. So there are 2 shells majorly here. We have the what? 1, 2. So this is first shell 1. The second shell is what? 2. That means lithium belongs to what? To period 2. And to determine the block is determined by the last what? Atomic orbital. So the SPDF. And the last here is what? S. That means lithium belongs to what? To block S. Now, another example we have here is what? Fluorine. So if you are to determine the group and period and block for fluorine here, what do you need to know? Now, if I'm going to ask you, if you check, this is 1s2, 2s2, and 2p5. Is fluorine going to belong to group 5? No, surely it won't belong to group 5. If you check your periodic table, fluorine is said to belong to what? To group 7. But let's verify that. And why is fluorine in group 7? Now, we are going to check. First thing, the group is determined by the what? The electron in the what? Last shell. So if you are going to check for this one, you have the first shell and the second shell. You can see 2, 2 at the back of what? Each orbital. So they are the same what? Shell. So this is what? 2 plus 5. That gives us what? 7. And the period is determined by the what? Last shell. The last shell here is what? 2. That's period 2. And the block is determined by the what? The last orbital. And the last orbital here is the what? The p orbital. So that was what? P. Now, you can also use the old form of the electronic configuration. It is for lithium. Now, for lithium, the old form of electronic configuration will be 2, 7. That's the old form. Now, in this case, these 2 electrons and this is 7 electrons. And this one represents the what? The last shell. So that means this is what? The group to which what? Lithium, which fluorine belongs. So that's group 7. And to determine the period, this is the first shell, this is the second shell, where we have the KL. So this is the what? First shell and the second shell. So in the second shell, it is what? This is the first, second. So that's period what? 2. And the last block, you might not be able to determine the block to which fluorine belongs using this what? This formula. But using the electronic configuration is it what? To determine. So now I'll be dropping some questions, and you can also try to determine the group, period, and block to which sodium, chlorine, magnesium, and aluminum belong. So try that out and drop your answer in the comment section. Thank you.